Okay, so 9a says this: without using technology, sketch the graph of each function, label all intercepts. So what we're going to need to do is we're going to need to find the roots. We're going to need to find the multiplicities of the factors. We're going to need to integrate the degree and the leading coefficient to find end behavior. We're going to see if there's no constant, so the constant is technically 0, so that's the y-intercept and so on. So what we need to do is we need to pull out a greatest common factor if possible, and of course we do see that there is a greatest common factor here of x. So this becomes x times x cubed minus 4x squared plus x plus 6. Whoops. Okay. So in that case, what we need to do is we need to now factor this cubic function. So we need to list some factors there, right? Factors of 6. And we need to find out what this is divisible by. So we need to figure out what p of negative 1 is, what p of 1 is, and so on, and just keep testing this until we get a 0. So let's see. Let's do p of 1 because that's easy. 1 minus 4 is negative 3 plus 1, negative 2 plus 6. That doesn't look like that gives us 0. Oops, that was this one. Right? So let's try negative 1. Does negative 1 give us? So negative 1 is, so that would be negative 1 minus 4 minus 1 plus 6. Ooh, that's looking good, isn't it? Okay, so this looks like it's 0. Well, if we did that math right, let's check by actually doing our synthetic division now. So let's put negative 1 there. Let's put our coefficients above. 1, negative 4, 1, 6. A little box for our remainder there. And let's do a quick synthetic division. 1, negative 1, add, multiply, add, multiply, add. Boom. Awesome. So we have x. This was for which factor again? Plus 1. This, because this was cubic, right? This was cubed. So this is going to be squared. So that's x squared minus 5x plus 6. Oh, yes, thank you. And then we have x here as well. Yeah, let's write that down. Absolutely. We can't forget about this one. Good. So now we can go ahead and finish this just by sight, I think. And this is going to be what? X minus 3 times x minus 2, right? Okay. So do we have any factors that are double or tripled up here? No, they're all separate. So this is what the function looks like. So what does that tell us? Well, over here, we're going to write down some intercepts. So 0 is an intercept from this one. Negative 1 from over here. Positive 3 over here. And positive 2. Looks like. So those 3 intercepts. Now, does the graph, where's the end behavior now? Well, if you look at the original graph, it's even. So it's either going to be 1 and 2, or it's going to be 3 and 4. The leading coefficient is positive. So that means that we've got this situation happening. We've got a 2 and 1. We good with that? Okay. So awesome. We're piecing it together. Each of these factors now has a multiplicity of 1. That means that at each of these zeros, we're talking about a straight cross. Just crossing. Not coming tangent to or anything. So that's pretty easy. We can just go like this, like this, like this, like this. Why is 0, 1? Because of this factor right here. If I let x equals 0, x equals 0. So we don't know how high or how low these dips go. And for us, right now, it doesn't matter. So this would be a rough sketch. Okay? So we've got negative 1, 0, we've got 2, we've got 3, we've got the end behavior. Is there anything we're missing? Okay? The only thing that I would like to do now is just to check to see if this matches up with a graph. So I will graph it just to check. All right, so if we graph this just to check, here we have an intercept of negative 1, an intercept of 0, 0, an intercept of 2, 0, an intercept of 3, 0. Does that look good?
Yeah.
Okay. The minimum point, the maximum points, we're not concerned about right now. But the end behavior, certainly 2 and 1. Okay, so does everyone see what we're doing there? And does everyone see sort of how that played out for number 9? Okay.